wallet. Ah, David Engelhart is already there. Whoops, I have to change.
He's so faithful. He's a good guy.
He is a good guy.
He's a really good guy.
Me. There we go. Now we got the II logo and everything. All right, so we are live. Susan's like, oh no, we're live. Is it live or is it Memorex? No, we are. We're live. And we got David Engelhart. We've got Laurel in Omaha. We are at, I scarfed up Susan Scarcey's.
Hello.
So am I saying your last name right? Scarcey?
Close enough. Susan Newman.
Susan Newman.
Works for me.
Okay,
it's easier.
It is easier.
And it's a good choice. Especially, since my daddy gave that one to me. So
There we go.
We'll take that.
That's perfect.
But the scarce goes along with it.
Beautiful. All right, so this is your first time on IEI News Live.
It is.
Yes, welcome. Thank you.
Thank you. It's good to be here.
It is. It is so good to be here. And we are here in Boston,
We are.
and we were at the Standards Council meeting.
Yes, and how interesting that was.
It was.
That was my first.
Yeah. I did my first appeal, and no matter how many times I come to these, it's all, and I've never done an appeal, but even being in the audience, just watching the process, it's like different.
It was. It was really, I don't know. It's, you sit through these and you sit through panels and you sit through other meetings, but this one had its own aurora to it.
It did. Yeah.
And it was quite interesting. The
Very
layout,
official.
Very official.
Yeah. Legal-like. There's a stenographer,
Yeah.
the whole bit.
The only thing I didn't do was swear in.
It's the truth. That is the truth. So why don't you do this? We got Lou Petrucci. Thank you for joining in. Steve, good morning. And she says, good morning, Susan. We got
Hello.
David Engelhart. We got Robert from Omaha. And Robert, get well soon, buddy. Got you in my prayers and all that jazz. So he's fighting a bug, one of those, I forget what it was, when you have a bad meal or whatever. It's,
Oh,
Yeah,
yeah.
so,
the
yeah.
poisoning in your system.
Steve Froming.
Hello, Steve.
Yeah, so we know everybody. So Susan, I don't know if everybody knows you. Why don't you let everybody know who you are and what you do and all that jazz.
I'm just a Susan. I'm Susan Newman Scarce. I'm hail from the state of Tennessee. Home is West Tennessee. However, I've relocated. I work for the military, U.S. Army, Fort Campbell.
Wow.
And it is quite interesting up there. It's a little bit different than outside of the fence, as we call it, or the wall, but it is very organized, and yet some things, aren't so much. So it's a different scenario. But the good thing is we adopt codes automatically.
Really?
In force, yes. That's the great thing about the setup with the military is once that code comes effective,
Yeah.
that January 1 of the following year, full code
Full code of enforcement. Oh, wow, I did not realize. So help me understand. You said Fort what?
Fort Campbell.
Fort Him, okay.
Fort Campbell, yeah.
Campbell,
Yeah.
okay. So
Home of the Screaming Eagles,
excellent.
101st Airborne.
Yeah,
Yeah.
wow.
It's Special Forces Group.
That's right.
We have some good guys up there.
Oh, absolutely. 101st Airborne is just phenomenal.
top notch.
That's easy company.
That's right.
That's
and
right.
a few others.
And a few others, that's right. Yeah, absolutely. So at this facility, you've obviously got barracks, you've got offices.
Yes.
And all of those are following the latest edition of the National Electrical Codes. What about 70E and 70B?
Well, interesting that you should bring that up. 70E has come into effect very strongly in the last, we'll say, 3 years or so, simply because for our Army inspections, and we call them the big Army inspections, but they will go through and they check everything on post to see what is in compliance, and they use mainly 70E because they also follow a lot of OSHA alongside that.
Sure.
We are not, I shall say, in full enforcement with 70B. It's a little bit different scenario
Yeah.
on that one
Yeah.
because we don't have manufacturing, that sort of thing. We have a lot of barracks, and by the way, that came into a big play because we have recently renovated like 15 of those. So
Oh, wow.
complete renovations.
Awesome.
So we've had a lot of that come up, and they fall under multi-family
Dwelling units.
dwelling.
Yeah.
And
Yeah.
typically, the dwelling on post is overseen and it is contracted through a different organization. We only usually help when we're called in for the housing.
Sure.
In our department, they have their own setup with their own inspectors. However, everything else on post that is installed, we are obligated to check that out to make sure it's safe for
Yeah.
mainly our soldiers and their families
Sure.
and to support the mission.
Yeah.
So it is a little bit different. We see all sorts of things.
Oh, I'm sure you do. I'm sure you do. Yeah. I know overseas we do. I've seen some cases like overseas whenever we have military deployed and they have to like manufacture. I don't want to say manufacture or establish a base. You know, and there's I know there's safety concerns there in the showers and all of that because you don't want to lose. You don't. You never. You know, it's just like anything. You put somebody through a lot of training,
Yes.
and they're a great asset to our country, whether or not it's a country or a business. You don't want to lose them because of some fault in a shower or in a bathtub or in a to shock or fire, electrical fires and things like that. So
Quite interesting that you would bring that up because several years ago we found to note that the military is the largest user of batteries in the entire
I can
country
imagine
or the
that, yeah.
world. So their thing is to be able to reuse these batteries, to recharge and
Sure.
reuse them. So several years ago, we found that there was a manufacturer of contractor selling more or less almost like a Connex setup for battery charging stations.
yeah,
And luckily, we walked up on it and noted that it was there and we had not inspected it. Found several misfractions
is
with
that right?
code.
Yeah,
We immediately drew attention to it. And unfortunately, before we could get that manufacturer shut down, there was a life lost
really.
across, yes, within the Middle East, in one of the posts. But we were able to shut that down to bring it up to compliance.
Yeah,
And that's what we find out a lot of the times is people will build things they want to supply, but
Yeah.
they do not get into the safety and compliance with code.
yeah. I'm telling you, code. And a lot of people lose sight of the fact that the code and the installation requirements are there to help for safe applications. It's there for life safety, and so that's I
Yeah.
appreciate what you do. But you do more than just that. I mean, you are also heavily involved with the NFPA development process.
Oh, wow. Yeah, it's been exciting, I will say. I started out as an alternate on panel one, did that a cycle, and did another panel, and then I went to the infamous panel 6
Nice.
as chairperson. So I have I think yesterday was probably my last big hurrah on panel 6 as chairperson. That completed my third cycle. And it has been exciting, adventurous, ups and downs. I will have to say it is a wonderful panel to be on.
Yeah, I can imagine.
We have gotten a panel that is very active and heavily involved, and that's what I appreciate. When people go and they sign up for these panel work, it is work.
Oh yeah, it is. Yeah.
And you see how much it is when you really put your heart and soul into it. And we brought on some younger group
Good.
of youth that are heavily involved. And I'm very proud of them because they were very active. And I'm glad that they're on the team. I hope they continue. I do want to encourage others, especially when you're out in the field. It makes all the difference in the world to be able to bring that knowledge
Oh, yeah.
that you've got
Yeah.
into the panel work. And we need more people on panels that have that experience.
So let me ask you, so you're stepping down as chair of panel 6, but are you going to stay engaged with panel 6? Are you still going to be on panel 6? What's going to happen? Come on.
Ah, that's
The
a little mystery
National Enquirer,
here.
the IAI National Enquirer wants to know.
Well, we're not certain which way. I
Okay.
do want to do another cycle. I'm excited for the revamping
Uh,
of the 2029.
oh my, yes, that's going to be a lot of work.
You know,
It has been a lot of work to date, but yeah.
it has.
Yeah.
And I can't imagine. So I'm just, and for all of us that we can say section 110 or section 310, and
Oh,
yeah, it's probably going to overwhelm me. So that's probably going to be it.
yeah.
But I'm excited for it.
Yeah, me
I
too.
would like to see where this goes. I believe in our industry, and I think we're stepping forward.
Mm-hmm.
So we'll see.
Yeah, we'll see. We'll all have a little bit to learn, but I
Yeah.
like for example, I'm just having a hard time right now because we moved Article 220 to 120. And my appeal was on 120.13, so I had to think in my mind. One of the council members asked me, well, "What section is it that you use for determining the load calculation for a dwelling unit?" And I had to go, okay, it was 220.41, but now it's 120.41 in my head. I have to do that transition, but we'll get there. And pretty soon it'll be like, remember when we went from dashes to dots?
Oh,
We used to always say, 110-14, 110-16. Now it's 110 dot. I can't, saying dash anymore to me is awkward.
yeah,
So it'll come new hat instead of old hat. So.
yeah. But what's really funny is when we type it in, sometimes I'll catch myself putting a dash in there.
Yeah.
So old
Yeah.
habits,
So seeing you here was very fortuitous because I've been having a discussion on IEI, and on today's topic, we got David Engelhardt, Michael Hofkins in the house too.
Hello, Michael.
Vinny B from Colorado, and Freddie B. So we've been having a discussion about ampacity, and today's discussion was going to be minimum circuit ampacity. In 210 we have and in 215 we have you have to do one calculation based upon the ampacity of the conductor, and we do the conditions of use. And then the second evaluation that you do is just based on 125% of the continuous plus the non-continuous. And I recently had a discussion with, who was it? I can't remember who it was, and forgive me, but they educated, I think it was Larry. I got educated, when we do things like that, we're like, okay, you do these two calculations, and then you determine the size of the conductor based upon the conditions of use, and then you determine the size of the conductor based upon the 125% of the continuous plus the non-continuous. And you lose, at least I lost sight of why we do that, right?
Yeah.
And I've been watching discussions, and so ampacity, and on the IEI News Live we went through this. Ampacity is for a conductor, and it's only related to a conductor.
yes.
And it's based on conditions of use, right?
Well, yes, because that conductor can do a lot. It is just like, it's amazing because the conditions change, and they make that conductor, whether it's more capable or less capable,
Yeah.
with conditions. The conductor itself, if you put it in free air, look what it will do.
Oh, yeah, that's a good point. Yeah.
But when we put that same conductor and start terminating it certain ways,
Oh, yeah.
or we try to bundle it up with a lot of other conductors, we change all the aspects around that conductor. It's still good for all of that,
Right.
but we just limit it
Yeah, so the conductor has an ampacity
Yes.
based upon the conditions of use, and it can handle that current indefinitely. So when I take that conductor, if I take a conductor and put it in a raceway, say 3 or less, right?
Yeah.
And I have the temperature, the ambient temperature is 86. Whatever is in table 310.16 it can handle that current indefinitely.
Good.
You're good. Now, when you terminate it on a say a piece of equipment or a lug that has 75 degrees C rating, the ampacity of the conductor is still what it always
Capacity
is.
is good, but
That
you
termination.
you just made a correction factor
Yeah,
right there, or you should,
yeah.
to that conductor, because, or the ampacity.
circuit.
The circuit.
The circuit, yeah.
Because you just put that little notch in it
Yeah.
for, trying to limit what it can do.
Yeah.
Just dropped it down. I don't know of any way we can increase a conductor's ampacity because it's good for what it's good for.
Right. Yeah.
But we can decrease.
Yeah, now, if I put it in a colder area,
Yeah,
there's the multiplier factors, right? So
yeah.
there's a table in 310 dot, and I know if I know Michael Hofkin's on here and crew, and Michael says hello, by the way, Michael Hofkin. So I know that there are some if I put it in a colder area and environment, I might be able to do like a 1 point something on the ampacity. That'd be the only way that I can say, because now you're cooling it.
Yes.
Right, so, but normally, you're in a warmer area that we see that. But then when we go to the termination,
That's,
now you're in 110.14, and so in my research, because I'm trying to understand this, and I've had these questions come to me, and they're like, okay, what's the right size conductor in relation to the overcurrent device? The limitation in 110.14 is on the termination, not on the conductor, the ampacity of the conductor, because the conductor can take what it can take.
it's true.
So in 310. And I brought this up yesterday, right?
Yeah.
And the reason I had to do that appeal was because we use one section for two things.
Yeah.
And I made the statement at the table, I said, I know of one other instance where we use one section for two functions, and that is 310.16. We use 310.16 to determine the ampacity of the conductor, but we also use 310.16 to determine the limitation of the termination.
Yes.
And
Yes.
I tell you what, as a young engineer, that was so confusing to me. I never could understand it. I would argue with the PE I was working under. I would say, what was his name? Bob. I'd say, Bob, I can't remember his last name. I said, Bob, I have an insulation that's 90 degrees C, and you're telling me I need to use the 75 degree C column. That doesn't make sense, because my insulation is not in the 75 degree C column. And he did his best, but to explain the reasons why we are using that one table for two functions is really difficult.
It's like if you have a drag car going down a straight line, you can get up a lot of speed and you can max it out. But when you hit a bend, you
Yeah.
can slow down. Same thing goes for us.
Oh, yeah, I like that.
When
Yeah.
we terminate, and whether we're terminating or doing other things with it, we hit a bend. We've got to slow down a little bit.
Sure.
So there are certain things in life.
Yeah, the race car can go, 150 mile an hour, 200 mile an hour, but when you're going around a bend, you're going to have to bring that race car down. I like the way that's a really good, and I love analogies.
Yeah.
I love analogies, and that termination is the same thing.
It's the same thing. That's
And
what we're
the
doing.
termination will have a speed limit,
Yes.
right? So I've seen those, you'll see
Hit
the
your
bend, it'll
speed
say
limit
limited to
right there.
30 or 25 mile an hour, right? So, and you're not supposed to go over that. So that's the other problem I've got. Or no, the other area that I see happening is they'll take 240.3B, and correct me if I'm wrong, guys, Willie Snyder, hey, Happy Tech Tuesday. They'll take 240, I think it's .3B or 4B, where you can go to the next larger for the conductor ampacity, and we'll apply that to the 75 degree C column for the termination. And you, when I have a limitation for that termination, if I say I'm going to go to table 310.16 and I look at a 1 odd conductor or a 2 and I follow the 75 degree C column because I'm landing on a 75 degree C equipment and it says 63 amps, I'm making it up. I can't go greater than, if 60 amps was a, I don't know 240.6, I should know 240.6 on what the standard ampere rating sizes are. But I could go, I would have to go down to the lower standard ampere rating because I can't exceed what that termination, because it's the bend in the road.
That's right.
And I can't exceed that speed limit. So that is a, if
We don't know if it's good, that bend in the road is good for 64 or 65.
Right.
But
And
we
I don't
know
want to
it's
go
good for
there.
60.
Yeah, we know it's good for 60. That's it.
Yeah.
So and then when I look at the UL standards, it aligns with the standards.
Yes.
So you follow the code, you follow how we test the products, and it all works out.
It does, and not only terminations, but you have other bends in the road or other hills and valleys
Yeah.
that can affect that too. So,
Yeah, and that would be, so I'm in my mind I'm thinking the temperature,
yes,
the number of conductors in a raceway,
correct. Yeah.
the termination. What else would I have for a what else would I have for a conductor? I'm trying to think. I think those are the only things I would. Are those the? I don't know. And I never want to say that's the only thing, because you know what happens. You end up in standards council and them going, you said that's the only thing. And that's not the case.
That's true. That is true. But so many times, and we're looking at terminations because that's something we're very familiar with. And every now and then, you may come across a different type termination. You know, we see 75 as the
Yeah.
majority.
Yeah.
But there could be some cases where we have some 60-degree terminations.
How about this one? And okay, so Laurel said it's 240.4Bs. Laurel out of Omaha, she's researched. Her and, so here's the other thing I remember, I learned. I was looking at an application and I had someone ask me, they said, it was like, say it was a 60 amp circuit.
Yeah.
And they said, is that NMB wire? And I was like, well, it doesn't make a difference because even NMB wire has 90 degrees C insulation. And they were like, whoa, 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 whoa. And, you know, it's those little details where you got to go to Article 3 something for NMB, and then you got to find out that, no, yeah, it has 90 degree, but you treat it with 60, right?
Yeah, yeah. So there's all sorts of places that, you know, we just have to take each step. That conductor is wonderful as long as it's just a conductor.
Yeah.
But when we take another step and do something else, then we affect
The overall of the I call
the
it
overall installation.
Yeah, and I look at it as a circuit. So in fact, I was toying with, do we need a term? And I don't know if we do or not, but do we need a term in the code that says this is the circuit ampacity? You know, I'm starting to. Okay, my mind's going 100 miles an hour because as I'm saying this circuit ampacity, I had another person say, Tom, maybe that's why we had the term allowable ampacity in the code.
You know, and isn't that they're trying to, that one is coming out?
We ixnayed that, and I remember when we took it out because we used two terms. We used allowable ampacity and we used rated, the ampere rating.
Yeah.
And so when I thought about we took the rating out because we said a conductor doesn't have a rating. It's an ampacity. It's all based on conditions of use.
Yeah.
And we took out allowable ampacity because we said it's the ampacity. And
It is, but is it?
right now,
Because we have the ampacity of that conductor, but is it allowed when we terminate?
that's right.
I don't know. So we may want to think about that one.
I agree 100%. That's the challenge when we sit down and look at the terms that we use and the applications, and you wonder, are we doing do we have the right language in there? And now when we took allowable out, and honestly, when I said I was looking at circuit ampacity, I was sitting there saying, I don't even like using the term ampacity because ampacity applies to the conductor.
That's true. That is true.
And when I deal with a termination, it's a limitation based upon the termination. So I can't exceed, if my termination says 63 amps, I can't exceed 63 amps. I have to protect it so that I don't go over the 63 amps. And that's not an ampacity value.
Well, it isn't, but together with that allowable ampacity, that is talking about what that's capable of doing.
What you're allowed to have
What you're
over the
allowed
circuit.
to have on that.
Yeah.
So with that, you know, in the printed edition, we took out a word and we probably saved a few pages, but with electronic now, you know, it's okay if we want to leave that. And sometimes I wonder if that is one word that we may have.
Well, okay, so, and here, and my opinion on that is, when you have 3 or 4 very good code experts
Yes.
that are ingrained in this system,
Yes.
and you look at the language in the code, and 3 or 4 of them will sit there and argue over what their interpretation is, that tells me that we need to add clarity. And when that task group, because I was a part of that task group that removed the term allowable, and I remember going through rated ampacity, and I remember talking about allowable, and if everybody sat there and said, I can't see a reason to have it, that's either because we didn't really understand how it was being used, and if you have a bunch of code people who don't understand how it's being used, that's an opportunity to say, we need to add clarity to the code.
True.
You know, I mean,
True.
and unfortunately, you and I, well, I'll tell you what, you've been doing this longer than I have because I was introduced, not that way, I was introduced to the IAEI late in my career.
Yeah.
And I remember going to I remember going to IEI meetings. Where the Ohio chapter was one that I always went to because it was really close. Western Pennsylvania, West Virginia chapter, and then the section meetings. And I would sit in there and listen, and I would hear them debate about the raceway and everything. And I didn't make raceway, but I was like, I was amazed at people like you who could shout off those sections and then talk about, well, you know, you go over here and then you go over there. And honestly, I didn't think I would ever, and I still not at that level, but I understand the code a lot more than I did years ago. But as a young professional who wasn't ingrained in the code, reading the document, I should not, our people in our industry should not have to have a degree in codes and standards to understand the code.
I am totally in agreement. We want people to read it.
Yes.
We should not make this so difficult that we discourage the everyday person in the field from wanting to know what the code says. Mm-hmm. And when we have done that, we've defeated our purpose.
Oh, amen to that. I agree.
You know, it needs to say what it's supposed to say, and no more and no less.
Yeah.
So I've always, and that came from a longtime friend of ours that has since left this earth, but it just needs to be simply said, and we do need to be able to understand it. And what's more important, the people in the field out there using it, or the people designing the jobs, or the people in manufacturing?
Oh, yeah. Yeah, everybody who is,
Everybody works together.
Exactly right. It is so important.
Yes.
Yeah, a lot of people miss this. That's what I love about the NFPA process. And a lot of people will say, oh, you know, one group, you know, manufacturers drive everything. Not true, because when you sit at that table, you've got inspectors, you've got electrical contractors, and we don't always all agree.
That's true.
But we get to consensus.
That's the one thing that one of our great mentors in NFPA has taught me, is Susan, sit down and make sure you're balanced.
Yeah.
From the very get-go. And that has been just the simplest thing that I could do, even assigning task groups.
Oh, yeah. Yeah.
as you well
Oh,
know
I know.
from
Well,
yesterday's.
absolutely. Yep.
And other times, but it takes that entire group to give that input. That's that's just why I really believe in the system. I believe in what NFPA does to establish that and try to get that uniform consensus across the panels to be balanced.
Oh, absolutely. And that I've heard a lot of people say negative things about the task group, and I've heard a lot of people say positive things about task groups. Panel 2 has been doing task groups since I first got involved. I mean,
Yeah.
if I go back, I can't even tell you what first edition that, because I used to sit around the wall on panel 2, panel 10, and 13, and watch the debates and learn, because there's just so much to gather, be a sponge. But panel 2 always had task groups, and I don't know if that was if that, I don't know who drove that on panel 2, but they did a really good job, because a lot of work was done before the code panel meetings. But that's not the end of it, right? Because,
That's the great thing.
yeah,
Is they do that work and they bring it to, but it's still incumbent upon all of the members of the
Yes.
panel to know everything that they're going to present.
yeah,
And I have seen a lot of task group work turned over when we got to full panel.
That's right.
And it was just simply things may have missed, misunderstanding, that sort of. But that's the great thing about having the full panel meeting.
yeah, absolutely right. And you're 100% right in selecting the members of the task group. And I know, like, when I ran task group 1 for code panel 2, we had a lot of people who wanted to be guests. And I mean, if a guest raised their hand on a task group, hey, you got something to add, let's add it. And it contributes to the discussion. So we had some really good dialogue, and I remember going through the dialogue on 210.52 with,
I bet so.
oh, I'll tell you what, and what was, you know, we had NAHB, oh man, I can't think of his name now, I can picture him, but we were working on 210.52, trying to come up with the arrangements, right? So, and the biggest argument points we had were, where's the connecting edge? Is it the wall? Is it where where the peninsula hits the T, X in all, or the T or whatever? So we had all these debates, and we were trying to come up with good language, and it's hard to come up with good language. It's easy to say I don't like this, but
Yes.
it's really hard to say,
Yeah.
how would you write what you want to do? And we would think we came up with the solution. And I'm like, oh, this is beautiful. You know, everybody's high-fiving. And then Dan Book would come walking over, and he would lay a picture down of a kitchen, and he'd go, how does it apply to that? And we'd go, oh. No, that is, where the heck did you get that picture? And we should prohibit that arrangement. So when you're trying to craft the language, it's really difficult. You know, it's not as easy as
is.
people think.
Because we have to remember what this code is written for. It's written for everybody.
Yeah.
And
Yeah.
not just a particular state.
Yep.
And not to be, torn apart by a particular state, but it's written for everyone.
That's right.
So it's a lot upon the panel
Yeah.
to
Yeah.
come up with that. And that's why, then again,
You need
it's so
public
important.
inputs.
Public inputs.
Yeah.
Yes.
Don't complain. Don't. Somebody said you're a part of the problem if you're not part of the solution. So make sure you make your public inputs.
Yes.
So Laurel mentioned 240.4b. David Engelhardt mentioned 334.80 for NM Ampacity.
Oh,
so that's
yeah.
in 334. So
Yes.
So each of the conductors, that was something that, honestly, I was like, you've got to look at the conductor you're using, because if it's
Yes.
NM, you've got to be mindful to go back to chapter 3 and look at the titles of the articles, because if you're using a conductor that has a specific article associated with it, you got to make sure you go there and make sure you follow the rules in those sections or those articles.
Hey, we just found something last code cycle that had been in there for years, and it was a duplicate of the same jacket in two different
Really?
categories. And I'll have to shout out to Mike Query from Texas. He caught it when he was teaching class, and he said, the problem is is trying to teach the students how to calculate. And I thought, you know.
Wow.
So little things like that happen over
Yeah.
time, but
Yeah.
it's corrected now.
Yeah.
So,
And so what I think it's really important, and what I started doing, and I should have done this a long time ago, I have on my computer and on which is also on my iPad, I have NEC, now I have an NEC 2029.
oh,
And
wow.
anytime I'm reading the 2026 code and you look through it and you go, wait a second, this can be done better.
Yeah.
I put that in and I write a little note to myself to say, possible public input
Good idea.
to add this clarity. And when you find these little errors,
Yeah.
some of those, I think, like some errors, if you submit them to NFPA, they can fix them as part of a errata, I think.
Yeah, this particular one, we had to figure out which it was
Yeah.
manufactured for.
Wow.
So it was not just
No, that wasn't errata.
not
that
just
was-
a comma in the wrong place.
Yeah, yeah, that's a big one.
So
Yeah.
just a little thing there, but yeah,
Yeah.
things do happen. We're
They
all
do.
humans, but yeah, the conductors. That's what I've been dealing with, the various conductors on panel 6, and it has been a great experience.
You don't handle raceway, do you?
No,
No raceway, okay.
no,
You handle the conductors.
yes,
What panel handles raceway? I can't remember. It's not 3.
no.
It's not.
Is it 5?
5 is grounding and bonding.
Okay, yeah, that's Mr.
Willie,
Steinman's.
Willie, David Englehart, Laurel's research. What panel handles
Yeah.
raceway? Because I can see raceway and conductors going together.
Sort of teaming up.
Yeah. Oh, so have you done task group work between code panels? Have you ever
I have
had?
not.
No?
I have not.
Never had to do that.
My first cycle, we combined to, was it 5 and 6? Some of the things that were mirrored on both, and we
Yeah.
combined. And then we broke away the medium voltage last time, I believe it was. So there has been a few changes along the way
Sure.
with that, but
Yeah. Well, CMP3, Willie Snyder says CMP, or I got Michael Hoffman says 8. Willie, I think CMP3 is your low voltage stuff. 8 I can buy.
3 is low voltage. That's
Yeah.
where I got between when I was on 1 and 6, and 3 was just, it was out of my realm because
Yeah.
I was used to being able to see, and that was my background. But yeah, 3 is low voltage.
Yeah. So 8 would be the raceway. 6 is the conductor.
Yes.
And cables. David Englehart noted that 240.4b applies when you don't have, it's to no greater than 800 amps.
Yes.
So
And it's only for services, isn't it? Is that,
no, 240,
is it?
240.4b, 310.
No, I know.
310.412.
Yeah.
310.12 is for services.
Yes. Okay.
Yeah,
I
that
got another one confused.
Yeah, I firmly believe that needs to be, so what I'm thinking of proposing is to take I think it's 310.12, which is, it has the 100 amp through 400 amp services, and it lets you go to a smaller conductor size because of
Yes.
the diversity. And we test panel boards that way. I found that in the standard.
Yeah.
So that was good. I think that section should be split and the service requirements be placed in 230.
Into
And
30
the-
with services.
Yeah, and the feeder placed in 215 with feeders, because that's,
Not a bad idea.
I would have never have thought to go to 310 for my service stuff, and I learned from Robert Osborne that it has to be, the equipment has to be listed and labeled, so I just can't use any panel board to use those smaller conductors. I've got to make sure that it's marked for
It's
use.
good for that. The labels on those panel boards are
Critical, yeah.
Yes, we're finding that out. Yeah.
So no sense putting a 185 amp load on a 180 amp conductor on a 200 amp OCPD. That needs to be added to 240.4b. Yeah, David, I think, I know I am going to be looking at public inputs for 210, 215, 230, 310.12 and 110.14. I tried this once before, I think twice before. I think this is going on 9 years now, but I have tried to get, I took table 310.16,
Okay.
I copied it, moved it over to 110.14C. I took out the insulation ratings because that has no applicability to the termination. I just had the conductor sizes. I had the copper and aluminum, and I said, let's reference 110.14 table 110.14C instead of table 310.16. Keep it all in 110.14 so that we don't double dip on 310.16. And I've been rejected so far. And I don't give up. I don't give up. I'm like a bad check. I keep coming back.
Well, and a lot of it could be the explanation, and this may be with 29 coming up when we revise all of those and try to
Yeah.
combine a sequence, a better sequence. That may be your opportune time.
Oh, I never thought about that. See, you know what? I was ahead of my time.
Yes.
Yeah, I had to change the entire structure of the entire National Electrical Code to get this done.
Get his thing.
Tom, what levels would you seek? Well, yeah, I started back 9 years ago, and finally, no. But I think there's something to be said, and it was in my testimony yesterday that I firmly believe we should never be using one section for two functions. It's not good for anybody, in my opinion. So
True, and then
it sounds
again,
like there's a but in there.
there sort of is, because is a lot of the times we look at, is that only applicable to one-time use, or is it a diversified? If that is for a one-time use, yes, that one place is all it needs to be.
Yeah,
But
yeah.
if it is applicable as referenced in other parts of
Sure.
the code,
Sure.
then we really need to make sure we've covered our ground to know where it is applicable.
Yeah, I can go with that. And I don't think that conflicts with what I have in my mind, because like 220.41, we're calculating the load for a dwelling unit. And then we use 220.41 or 120.41 to also determine the number of branch circuits.
True.
And it's technically two different things. And so I can see that being separated out, but other applications, like you just said, with the one section may have different applications based upon conditions or whatever, then yeah, I can buy that. I think we're
Okay,
we're in violent agreement.
We're getting there.
We're getting there. All right, so I'm looking, David Engelbart says, you can put a 55 amp conductor on 60 amp breaker for a branch circuit. If it's if it's a non-continuous load, okay, so here's what I would do. I don't disagree with you, but I would have to look at the 75 degree C column. If it's a 75 degree C piece of equipment,
Yes.
you have to have at least your 60 amp breaker has to be able to protect that termination.
Yes.
Because if your termination is only 50 amps, then you're going beyond. If you have 55 amps worth of load going through a terminal for the size of a conductor that's only rated for 50 amps, you can't put 55 amps through that load
That's
continuously.
true. You're
Yeah.
going to the next higher overcurrent protection level.
Yeah, and that would put you at an overcurrent protective device that is greater than what is needed to protect the termination. Not bad for the conductor.
Yes, conductor is good.
The conductor's good, but now you're
Yeah.
worried about the termination. So
The terminations is what you're actually, which goes back to ours. That conductor is the straight highway.
exactly. And that's the challenge I think we have with 210 and the minimum circuit impasse or the minimum conductor size. And then so that was the other thing. Article 210 has that section, and it's titled minimum conductor size and ampacity or something like that. I can bring up anything, but I'm not going to do it. So it has size and ampacity. And we had the discussion, somebody said, well, you don't need size if you've got ampacity. And I thought, well, that sounds logical, but.
Oh.
Exactly. But.
Yeah. So is the size not going to matter when we terminate, when we start putting it in a raceway, when
That's
we
right.
start making bends?
That is exactly
Does that size
right.
come into play?
Yep. Yep. And it comes into play with the termination. So if I'm doing 125%, I'm no longer dealing with ampacity. I'm looking at 125% of the continuous plus the non-continuous. That has nothing to do with ampacity because that's a 110.14. That's an equipment issue.
Yeah.
So then on the ampacity, so this was my discovery. And Larry Ayer and I were talking about this because I'm like pulling my hair out and I want to make sure I'm doing the right thing. And Larry was like, I told him, I walked down through my process and I said, okay, I determine the ampacity. I take whatever my load is and I take the conditions of use and I take the multiplying factors and I divide by the multiplying factors to increase my load current. And then I say I need a conductor with an ampacity. If it's a 90-degree C column, I go to the 90-degree C column and I find an ampacity value that is greater than this number that I've adjusted and increased because I divided by the multiplying factors. And then I'm good for the first one. And I say, okay, that's the size conductor there. Then I look at the 125%. And if I'm on 75-degree C equipment, I take whatever that 125% times the continuous plus the non-continuous, I take that number. And then I go to table 310.16 and I come down the 75-degree C column till I find a number that is greater than or equal to that number. And I take that size of the conductor. So now I've accounted for the ampacity and I've accounted for the termination. And what I used to do was go to the 90-degree C column on the 125%. I'm like, well, that was wrong. I have to use the column for based on 110.14. So, and that gets me my two sizes, and whichever one is greater. And I'm like, now that makes sense on why we have the size and ampacity, because ampacity is only one of those two calculations.
That's right. It's only part of the equation.
Right. And it's so complicated. Why is it so Susan, fix
Well,
it.
You know, maybe it's not. Maybe we're not breaking it down and taking it one
Yeah.
bite at a time.
Oh yeah, no, you are absolutely right. So what I did on I was one of these IEI News Lives. We broke it down. We said, okay, we're going to go through 210, and we're going to do these two calculations. Then we're going to go to 110.14, and then we're going to go to 210 again, and for a branch circuit, 215 for feeders, but we're going to go back to 210 and select the overcurrent protective device, which has to take into consideration the temperature ratings.
That's true.
And when you break it down,
So
then you have a maximum you can go to one step larger on the ampacity. You can go one step larger on the ampacity. You have to make sure your circuit breaker is at least 125% of the continuous plus the non-continuous. And then the third one is I can't exceed whatever's in that column for 110.14 if it's a 75 or 60-degree C piece of equipment. And then you got to pick your overcurrent device to be in to meet all three of those criteria. And then if they don't, you increase the conductor size and do it again.
You do. And, and each level, if we miss a step,
Yeah.
we just stumbled.
Yeah.
So we've got to take this step by step to get where we need to go.
Yeah. And honestly, I think it's easy to want to skip steps.
It is for us, naturally.
It's human nature.
We want to go to the end result and say,
Yeah.
oh, you just need a number 10. Don't ask me why.
Don't ask me why. Yeah. Oh, and I wonder how many people how many installers, designers, and I'll even throw out inspectors will take a conductor that goes through an attic that could be upwards of 140 degrees Fahrenheit for a good portion of the day,
Yeah.
and says, I'm going to do the ampacity calculation for the conductor that's in that attic and adjust and determine whether or not they have the right size conductor. I don't think that happens.
Let's just say, is anybody on here that has ever done that?
That's a good question. Michael Hofkin. Have you ever done, well, Michael, yeah, Michael, have you, David Engelhardt, Willie Snyder? Oh, wait, we got stuff coming in. What's the reason the NEC doesn't require the consideration of voltage drop for branch circuits under 1,000 volts? Isn't there's a section?
Remember that ampacity on that conductor is good.
Oh, that's right. Yeah, and the impact. So oh, that's the other thing. So, oh, that was the other issue I had with 110 to 14. So good point, Willie. We'll increase the size of the conductor, and when you increase the size of the conductor, that new conductor size has a higher ampacity value. And,
It does.
And what 110.14 does, and I firmly believe it does it incorrectly. It says the ampacity of the conductor cannot exceed the rating of the termination. Well, I can have an ampacity of the conductor that's a much higher value. I just have to protect
You
it.
do. It's the protection of it.
Right, it's the protection I
But
think,
and in some cases, if you actually do the rest of the things like adjust for temperature factors,
Yeah.
you're going to have more than that.
sure, yeah. So when I look at 110.14 and I say, okay, what they're really saying is don't put an overcurrent device on there that is greater than what's in the 75-degree C column or the 60-degree C column, because you need to protect it at that number. It has nothing to do with the ampacity of the
That
conductor,
conductor. That's true.
because the capability of the conductor is the capability of the conductor.
Because actually, you want that conductor, to carry all it can carry.
You need that
You
conductor.
need it. Yeah, that's right.
I feel like, what is that? A Few Good Men. You want me on that wall. You need me on that wall.
That is true.
Yeah.
That needs to go in your book.
Yeah, and somewhere I got to work in. You can't handle the truth. I love it. But, okay, so to further clarify that 240.4b is not limited to service or feeder conductors. That is true.
That
Yeah.
is, yeah.
And she was thinking of 310.12.
Yeah.
The answer Michael Hofkin says, the answer I've always heard is that voltage drop is a design issue that may be wrong. That may be wrong. So here's when it comes to voltage drop, I agree that with you, it's not about what the conductor can carry. It's all about what the end use equipment can handle.
User. And
Yeah.
do we know that?
In some cases,
In
if it's a
some
motor,
cases, you know that, and
Yeah.
you can adjust then. But in residential applications, how do we know?
no.
Sometimes we may know that it's a kid's room, that's a teenage room, going to have 50,000 things plugged in.
Yeah.
But is that enforceable? Are we inspecting or expecting?
Ooh, that's a good. Ooh, I love that term. I've used that. I learned that at an IEI meeting. In fact, I've used that internally. I've had some. My manager says, "You're not hitting your goals." I say, "Are you expecting?" See, there's that expecting thing again. David Engelhardt says voltage drop is mostly an energy code requirement, except for fire pumps at IT equipment in the NEC. I agree, and we can have the discussion and debate on should voltage drop be a part of the equation. And I don't necessarily disagree that it's an application-driven issue, because I might be perfectly fine with a voltage drop, depending upon the equipment.
I think that comes back to good engineering practices,
Yeah,
whether it's needed, necessary, or not. I really think that's where it comes into.
yeah. And to craft the language appropriately, especially like you say for a dwelling unit, you'd have to be very careful on how you craft the language to not get very unruly with it, But
And I'll agree, it's not a good practice if you are an installer to run a 250-foot run, back home run, back from some detached garage or upstairs. It's not a good practice.
No.
But know your electricians, know your contractors, know the quality of work, and look for quality.
yeah, no, yeah, oh
It
yeah.
costs the same.
That's right. It costs the same. That's right. Yeah. David Engelhardt says not to forget 250. Yeah, I knew it was in 250.122b. So don't even start me on 250.122. I have a pet peeve with 250.122.
Oh,
I have a big pet peeve with that. And here's my pet peeve. I tried to understand why. I always ask the question why. So I was at a North Carolina, I think it was a southern section, I think it was the South Carolina chapter, and I was given a question about two air conditioners on a roof and what size conductor and overcurrent protection, blah, blah, blah. And there was one last little thing, it says, and what size equipment grounding conductor? Okay. So so I think it was that, yeah. So I did everything except the last part. And somebody raised their hand and said, well, you didn't answer this. And I was like, oh, I didn't even see it. I was so caught up in the ampacity. So I said, I'll do that. When it gets back to me, I'll have it done, right? So it comes back, and I went to the tables, and I answered the question. And then I was sitting there wondering, why?
Yeah.
Why do I need to increase the equipment grounding conductor size? So I asked the question to a few people on panel 5.
Yeah. Good place to start.
Good place to start, and I went to some of the more vocal, educated people. Well, they're all educated, but I went to the more vocal ones, right? And I asked them, I said, well, why do we do this? And they were like, well, the one person said, well, Tom, whenever you increase the size of the conductor, you're going to decrease the impedance, which will increase the fault current. And we care about fault current, so it's about interrupting. And I'm like, okay, I'm gonna go with that. I said, but if I have a 250-foot run,
Yeah.
and I have a voltage drop issue, and I go from, I don't know, a 1-aught to a 2-aught, my impedance change and my fault current, and I did the calculation. I did the calculation, and I went from, like, say with a beginning fault current of 10,000 amps, I increased it 800 amps because of the increase in conductor size. And I said, so we're worried about 800 amps. I can increase the fault current way above 800 amps if I shorten my conductor.
Yes.
I can get it to close to 10,000 amps if I just have that conductor 4 inches, okay? So why would I be worried about an increase in fault current when I increase the conductor size, when I can increase it tenfold by shortening the run?
Yeah.
And then it was like I got the deer in the headlights there. So then I asked somebody else, and they said, it's because the circuit breaker won't trip. And I was like, oh. So I increased the conductor size, and I've got this long run, and now you're worried that the breaker won't trip. I says, well, isn't that? And they said it was about shock. And I said, well, GFCI protection is about shock. It's not, grounding and bonding is not about shock. Yes, I have to trip the breaker, but
Yeah.
if I have to trip the breaker, if I'm on a 100 amp circuit, all I need is 100 amps of ground fault current to trip the breaker.
Yeah.
So when I went back to my calculation, I'm like, I do my ground fault calculation, I exceed 100 amps or whatever the number was. I'm way higher than the ampere rating of the thing. So I still have yet to find someone who can educate me on why I increase the equipment grounding conductor size when I increase the ungrounded conductor size, because it's not about fault current and it's not about not tripping the breaker. I don't know what it's about. I really don't know.
Sell more wire.
No. Oh. To keep panel 6 happy. So
We got to support panel 6.
we got to support panel 6, yes. But I did not. So what I did was I said, okay, I can get, if I have a current less than, say it's a 100 amp breaker, if I have a ground fault out at the end of that run, and it's less than 100 amps, and I don't trip the breaker, and I have a living ground fault, and I don't have ground fault protection, I get it. So I said, what if I had ground fault protection of equipment? Or what if it was a GFCI protected circuit? Then I should be able to trip. Yeah.
Then.
And so I got an exception in that lets you go back. It points you back to 250.2 or something that just says basically when a ground fault occurs, you have to have a ground fault current path that will trip the overcurrent device. And if I have ground fault protection of equipment, I will trip the overcurrent device.
And if you don't, then that conductor sizing plays an important role.
And so here was my argument there. So then someone else said, well, you'll overheat the conductor. But if I'm, say it's 100 amps worth of conductor, and I have 50 amps flowing through the equipment grounding conductor, the bare copper conductor, I'm not going to hurt the insulation on the ungrounded conductor because I'm half of what it can handle indefinitely, as long as the conditions of use are there. And if it's a bare copper conductor, there's no insulation for me to damage. I'm not going to anneal it. I'm not going to vaporize it because the fault currents are not high enough. So it's a load on the circuit. The breaker will let that flow, and I can understand that, okay, I might have an energized piece of the circuit that if somebody ends up touching it, now I have a shock hazard. I get that, right? And you don't want that condition to exist, but I would have to have a very low ground fault current to not trip, because I don't have to trip the breaker in the instantaneous region, because the breaker may not even have an instantaneous. I can't say I have to trip it in the short time delay region because the circuit breaker may not even have that. So it would be,
More to continue on that. That's quite interesting. I think
I'll never forget the discussions, because I was just asking the question, because I want to understand. And the one individual was so angry at me. His neck was red, and he's like, "You just don't understand. You should read Source and Grounding. Source, Grounding, and Bonding book." So I did. I went and I grabbed the Source, Grounding, and Bonding book, and I read it through. And I went back to that gentleman, and I said, "Okay, I read through this." And I had the book with me, and I said, "Show me where because I can't find it." And then he goes, "Oh no, you need one of the older versions." So I found like the second or third edition, bought it online, and I had it on a plane. It was a short little book, and I read that thing from cover to cover twice, and I said, "I still can't find it. Where's it at?" And I never got a response. So I'm still looking. Somebody out there can explain to me why we do that. I would love to see it. But I'm happy with where 250.122 is now, because there is an exception that lets you engineer a solution.
Yeah.
And I think ground fault protection of equipment is a good solution that says, look, I'm going to protect that equipment grounding conductor.
And I'm in agreement with that, because the ground fault protection, it protects equipment and people.
Yes.
And what more could we ask for?
Yeah.
So, and we, as the industry, there are people fighting against ground fault protection in so many ways. And I'm thinking, is that not the best thing since sliced bread for us?
It's a technology. It's an old technology. It's getting better.
Look how far it's come.
Oh my goodness, yeah. Remember when it first came out?
No.
Oh, I don't either, but
I've heard stories.
I've heard stories about it. Yeah. It was pretty controversial when it first came out. Yeah. I was just a youngin. But
electricity? What was that?
Electricity? Yeah. I grew up on a farm. Steve says, unless you do the calculation and determine a certain length will conduct enough to trip the breaker. Yeah. Now, Steve says in the instantaneous, there is nothing in the code, Steve, that says it has to trip in the instantaneous region. Because if it did, then I would not be able to do selective coordination, because selective coordination, I will have to be in the short time delay or long time delay.
Yeah.
And if you look at 250 it's an early number 4 or something like that, it just says it has to trip the overcurrent device. So I can trip it in the long time region. I can trip it if I have a 100 amp breaker, as long as my ground fault current is greater than 100 amps, I'm good. It doesn't have to be in the instantaneous region.
I have to make confession right here.
All right, so go and sin no more.
No, it's something that I have had all the years, and it scares me. And I know that engineering practices, it's the best thing, and especially manufacturing. But these adjustable trip breakers,
Yeah.
I'm sorry, but they
You don't
scare
like
the
'em?
crap out of me.
I agree. Yeah.
Because it's too easy to go, and if they're having a problem, to change that. And as inspectors, we don't know what that setting should be.
I know. And so here's the thing. In 240, we have the permission that you can dial it. So you have a 400 amp frame breaker. I can dial it down to 100 amps.
Yeah.
And I can say, Now it's a 100 amp circuit. I can put 100 amps worth of conductor on it.
Yeah.
Right? And then if you look, it says, if I have it in a room that's locked, I don't need to lock the cover of that breaker, right? Because it's in the room and only a qualified person should be in that room. But I don't
Should.
Yeah, should. And I don't disagree with you that there is, I think there's I don't know. I don't know how you would fix it.
I really don't, because I believe in them, but at the same
Yeah.
time, it's
scary.
really scary for me.
Oh, it is. And then here's what happens. And I do a lot of education with electricians and whatnot. And my biggest fear, I know when it leaves the factory, it's always set at the lowest setting.
Yes.
Okay, so you have to really, you have to consciously move the dial to put it to where it needs to be. Okay, so and I would hope that whoever's doing that. But my biggest fear is when it's on a load and it trips. And say it's a motor load or it's a transformer. And then when you look at, not every device is the same. And you look at the dials, and I just fear that somebody's going to say, well, let's turn this one up and try to re-energize.
Oh, it happens more than you realize it happens.
And if now you have a 400 amp breaker with 100 amps worth of conductor, and it's set on 400 amps. You know, and 70E, I know
We
70
found
has.
it.
Oh, really?
Yes, yes.
Yeah.
Not good.
That's the challenge.
Not good.
I don't. It's not. I agree. It's not good.
But,
It is not
you know,
good.
I understand the principle for them and
Yeah.
the purpose and, you know, but that's part of it. If any of you are in training, please teach them, you know,
Do not touch that dial.
that, yeah, do not touch the
Yeah,
dial. Leave
unle-
your screwdriver in your pocket.
Yeah. Leave it back at the truck, and then if you are going, and then the other pet peeve I have is, we ship the products out, and we do a coordination study, and somebody paid a lot of money to get that done, and then nobody goes back and changes the settings for each of the circuit breakers to assure they align with the study. And now you've paid for a study, you don't have you don't have the performance of the system that you thought you had,
Yeah.
and everybody looks down and says, well, it wasn't my job to do that. It wasn't my job to do that, you know?
We just threw the whole thing out.
Yeah, I walked into this goes back into the 90s when I started at Eaton. I had a very large customer of ours that I was working with, and we did power quality studies. We did their short circuit studies, and the individual that was managing the electrical system was not an electrical person. Okay, it was more of a chemical person. And I go into the site, and they're taking a bunch of equipment, and they got it all apart. And I was like, well, what's going on? He said, oh, we're redoing this, we're changing the breakers because we had a fault, and this upstream breaker tripped, and it didn't clear it here. And I was like, oh, I said, well, who set your breakers? And he goes, what do you mean? I said, well, the dials on these. I said, who set those for the coordination study that we did? And he goes, oh, no. He says, we take factory defaults on all of our overcurrent protected devices. And I'm like, oh, no. You can't do that. That's ungood. And that's probably why you had a trip upstream because you had the lack of coordination. And we did a coordination study. Somebody was supposed to change those dials. He just didn't know, you know?
And that
And it was an
happens a
education
lot.
process.
Yeah.
Yeah, you might be
Yeah.
probably right. You're
It
probably right.
unfortunately
Yeah.
does.
And you wonder how many of those breakers are out there that have been modified and they're not really protecting the conductor.
Yeah.
Wow.
The real world.
That's it. Oh, yeah. I remember I was in a meeting and I made a statement, and there was somebody sitting at the table and they said, well, Tom, in the real world. I'm like, all right, I got the message. It felt like my cousin Vinny. I think, I understand. Oh, no, you don't. So.
Go with me, I'll show you.
Yeah. Okay, Steve, Laura, it's been a wonderful discussion. Thank you, Laura. It's 1 o'clock, so we're over time. And then Steve says the code doesn't say the nature of the tripping, and perhaps it should require enough current to get you into the instantaneous, so there's no delay. And Steve, that proposal's been made and rejected. I think in this code cycle, they were trying to do the instantaneous region or the short time delay. But the reason it is not good to do that is because of coordination. You would never, if I made sure that all of my circuit breakers tripped or fuses opened in the instantaneous region or the current limiting region for all ground fault currents, I would never be able to selectively coordinate my power distribution system. I would never be able to coordinate anything because I would have a cascading outage. Willie Snyder says, I have to watch the TCC show so I can set it correctly. Yeah, you gotta watch you gotta come back to IAEI News Live and we'll do a TCC show. All right, Michael Hofkin, thank you. And Michael Hofkin says, thank you, Susan.
Thank you, Michael, and group.
And Steve Frumming says, great chat. Was not just Tom. Yes. I try to, I saw Susan and, here's the thing. It's hard. I ask a lot of people and they don't want to go live. They don't feel comfortable. And I'm glad you did.
It's just Susan.
It's just Susan. We could do a show. It's just Susan.
That's right.
I can see it. I would love it. It's just Susan. Boy, we could definitely.
Tell him what would come up. So.
That's right. That's right. All right, Steve. Thank you. Thank you, Robert from Omaha. And he says thank you. We have Wayne Janik. And thank you, Wayne, for joining in. And Michael Hoffman, smash that like button, hit that thumbs up. And remember, if you're going to hit the like button or you're going to hit the thumbs up, you got to do it twice.
Oh.
Yeah. No odd numbers, please.
Okay.
All even numbers. Twice, 4 times, 6 times, 8 times.
Give it all you got.
Yeah. So, anyway, there we go. We got a thumbs up. So, all right. And Steve says, thank you. You are great, and thanks. You are welcome.
Thank you, group.
All
Yeah,
right, guys.
Appreciate being here.
Yes, thank you for taking the
Thank
time.
you, my friend.
And you're going to drive me to the airport.
We are.
We're going to go to the
headed
airport
back
next.
to other parts.
Absolutely right.
Yeah.
It was a great job yesterday, and thanks for. I really appreciate you. Thank you.
Well, you have been a friend to the industry for several years, and we
appreciate that.
do appreciate that.
Excellent. Thank you.
Great.
All right, everybody.
Take care,
Stay safe, and please stay healthy.
above all.
Yes. Amen.
Say your prayers.
That's right. And we go to, watch this, I go to, boom.